Welcome students. Let us solve some numericals related to your potential energy and potential. So this is one question, you can write it down. Four equal charges Q are brought from infinite to the four corners ABCD of a square of side A as shown. Compute the work done in required in bringing first one the first charge, second the second charge, third one the third, fourth the fourth, fifth. What will be the electrostatic potential energy of the whole system? So what should be the potential energy? It should be the combination of all work done, right? So let us solve it. This is the figure given to you, right? So you can draw this one, right? So from infinite, let us start with point A. Okay, from infinite I brought one charge Q from infinite to point A. Okay, how much work I did? I did no work because no other charges were present, because first I brought Q and I placed it here. Okay, so let us find it out. What is the work done? Work done upon a unit charge, you know it, this one is potential difference, right? So what is work done due to A is equal to, work done on A is equal to Q into VA. Okay, so what is the potential VA of that place? 0, right? And we are doing no work, right? So Q into VA is equal to 0. Charge is there, but what is the potential difference there? No potential difference, because no other potential is present. So answer is 0. Okay, now come to the second part. This is the first part over second part, VB. So when you will place this Q charge to this point B, now you need to do work because this is the same charge, so there will be some repulsion and there will be some work done, right? So that work done is BB, WB is equal to Q into BB, right? So what is your VB? VB equal to, you know the formula of potential, don't forget, that is Q by 4 pi epsilon naught into A. Yes, because the charge is Q everywhere. Okay, and which Q is this one? This Q is nothing but this one, right? So what is work done? Q into VB, right? So this will be Q square by 4 pi epsilon naught into A, right? So now YA, the distance is A here, right? All the sides is having a distance how much? A. So let us now find out VC. VC is same 1 by 4 pi epsilon naught Q by, okay, there will be two Q's, because when you bring your VC there will be already two charges present, one at A, one at B. So one distance is A, another distance is this one, the diagonal distance. Okay, what is this distance? If this is A and this is A, so this will be your Pythagoras theorem, root over of A square plus A square, root over of 2A square. So this is root 2 into A. This is your root 2 into A, right? So one distance is Q by A root 2, another one is plus Q by A, right? So work done WC equal to Q into VC. So 1 by 4 pi epsilon naught Q square by A into 2 plus 1 by root 2. If you simplify, this will come. Now let us find out for VD. For VD, when you place the charge at D, okay, how much you have to work? Already these all charges are present. Okay, so one distance is this one, due to this one repulsion will be there, due to this another repulsion is there, and due to this diagonal repulsion is there. What is this distance? Root 2 into A. So there will be 3 plus, okay, this Q by 4 pi epsilon naught into A square A, and another one is this one Q by 4 pi epsilon naught into root 2A, and this is another one, q by 4 pi epsilon naught into root a. Okay. So let us write it down. Vd equal to 1 by 4 pi epsilon naught q by a plus q by a root 2 plus q by a. So work done due to at d is q into Vd, that is 1 by 4 pi epsilon naught q square by a into 2 plus 1 by root 2. Okay. So let us come to the fifth one. The fifth one is total work done or energy calculation, right? So energy calculation is nothing but total works WA plus WB plus WC plus WD. WA is 0 plus you place all the values and just make it common, you can make it, okay, and you will get the answer 1 by 4 pi epsilon naught q square by a into 4 plus root 2. If you solve this one also, not an issue, you will get another answer, right? This is your final answer. Let us solve another one. 2 point charges of 0.12 microcoulomb and this minus 0.06 microcoulomb are situated at a distance of 3 meter from each other. Calculate the electric field and potential at a point midway between them. How much work will be done in bringing a charge of 0.2 microcoulomb from infinite to midpoint P? Right? You can write it down. So you can draw the diagram like this. This is plus charge 0.12, this is minus charge minus, okay, this is 0.06. Let us take the magnitude, okay, and this is the point P which is present in the midway as according to the question, right? Now let us check what should be the electric field. Okay, let us find out the magnitude of electric field E1 and E2. What is E1? E1 is nothing but electric field due to A, okay, due to charge at A. Okay, who will experience? Who will experience? The P will experience, right? So at P, two electric field lines will come. One is due to this plus charge, another one is due to this minus charge. So let us find out first the magnitude value. E1 equal to, you know the formula of electric field. What is the formula? Q by 4 pi epsilon naught into divided by r square. So 1 by 4 pi epsilon naught value is 9 into 10 to the power 9, you know it very well, multiplied with Q value 0.12 into 10 to the power minus 6. Why? Because it is in microcoulomb, right? Whole divided by, what is the distance? If it is present in midpoint and the whole distance is 3 meter, so what is the distance from P to this one? 1.5. So 1.5 whole square. So you will get this answer 480. So similarly E2 also you will calculate for 0.06 charge. Take the magnitude value and you will get the answer 240 Newton per Coulomb. Now let us check the direction. Due to plus charge, if I will place a test charge of plus here, okay, plus Q, right? So plus and plus, what will be there? Repulsion. So the direction of electric field E1 is this side. So this is plus and this is minus. What should be this one? Attraction, right? So this direction is also this side, E2 direction. So both are in the same direction. So what should be the net electric field? The net electric field E equal to E1 plus E2, that is 720 Newton per Coulomb. You need to only add these values, right? So the potential at P due to positive charge at A, right? So now we will calculate the potential as it is being asked. So V1 equal to, formula is Q by 4 pi epsilon naught into R. So 1 by 4 pi epsilon naught value is what? 9 into 10 to the power 9 into Q value divided by R. What is the distance? 1.5. We are finding the potential at this point P due to this one, right? Now at B we will calculate, okay. Okay, so this will come as V2 is equal to minus q by 4 pi epsilon naught into r. Why minus? Because as this negative charge is present, so work done will be negative and the potential you will get also negative. You can refer the derivation also. Okay, so the V2 is minus q by 4 pi epsilon naught into r. So place the value of q, that is 0.06 into 10 to the minus 6 all divided by 1.5, we will get minus 360. As potential is a additive quantity, what you will do? V equal to V1 plus of V2. This is 360 volt. Okay, so now what it is asked in the question, how much work will be done in bringing a charge of 0.2 microcoulomb from infinite to midpoint P. What is the charge given? 0.2 microcoulomb. So it is asked work done. So work done formula is Q into V. So Q value 0.2 into 10 to the minus 6 as it is given here at this last line, 0.2 microcoulomb, multiplied with V. What the V you got? 360. So the answer is 7.2 into 10 to the minus 5 joule, right? And again I am telling you what is your V1 and V2. V1 is nothing but at point P one test charge is present, so we will bring this plus Q and we will do some work by moving it to this side and we will calculate the potential. This is known as calculation of potential for point P due to charge at A, right? Similarly we will calculate for B, okay, by moving this charge to this side, right? Okay, and that work will be negative as you have seen in the derivation. And students, it's a biggest request to all of you, go through the derivation first before you go to the numericals. You have to go to the derivations first. Thank you.